The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning everyone. Welcome to this webinar from Blueback Reservoir. The topic of today is geophysical interpretation and analysis. So this is the third series in the GDI webinar series. So the focus has been on our Geodata Investigator. So today we're going to show the GDI, which is our domain, cross-plotting and analysis tool, which has some unique features like matrix plot, being able to visualize all your dimensions together in one nice plot, some classification workflows which let you plot and interpret your data, and you can also produce some equations and statistics. The GDI supports nearly all the Petrel objects, which you can plot together in the same space, so you can work with wells, models, seismic, surfaces in attributes, point set, and models, etc. Today we're going to look at geophysics, and I will use some seismic data and logs that I've created using Blueback Geophysics tools. But equally, you can get these seismic cubes by using other tools outside of Petrel, or by using the various volume attributes, calculators, and other processes inside of Petrel. So just a note on how this session will work. We're using a GoToMeeting. You can close and expand your panel using this button. You can switch between full screen and window to see better resolution. By default, everyone is muted, so if you have any questions, please enter them into the text dialog, and we'll take some time at the end to cover them. We hope to have the recording of this morning's webinar up on the Media Center within 24 hours. So just to start, I want to briefly mention what our aim is with geophysics. So really what we're trying to do is to make quantitative interpretation much more accessible to the everyday interpreter. And how, you may ask? Well, firstly, all our geophysics tools are integrated into the interpretation package, in this case Petrel, so you don't have to leave Petrel or leave your interpretation space to do any of this work. And secondly, at each stage of the process we can use the GDI to help QC and analyze the interpretation that we're doing. So it's really a kind of iterative process between interpretation and analysis. So what does that mean? Well, really at any stage of your workflow, whether you're doing an AVO investigation, whether you're looking at some inversion type data, or whether you're doing some maybe rock physics like fluid substitution, you can take the data into the GDI space to help you get a bit more confidence with how the results are looking, so that you can have a better control on some of these algorithms that you use. Of course, we need to be able to both get data into the crossplot and get data back out. So using GDI, we can create point sets and interpretation which help us go back into our interpretation space, which is critical when working with this type of data. So today I plan to show how to make a simple reconnaissance using your angle stacks to see if there are any AVO effects on your seismic. We're then going to produce a intercept and gradient and try and classify such a response using an AVO classification. We're also going to look at producing a extended elastic impedance attribute and bringing that into the crossplot space to see where I might have correlation between my AVO effect and any fluid effect in my seismic. And finally, I'm going to show a little geophysical workflow using some geophysical logs and integrating that with some rock physics models. So today I'm actually going to cover a little bit of all of our geophysics products, but of course the focus will be on the Geodata Investigator itself. For more information on any of the tools and processes seen here today, you can go to the Blueback Media Center which you find on our website. Once you're at the Media Center, you find access to previous webinars, how-to videos on the software tools, then some posters and click-through guides with some more detailed workflows on the software. It also has a link to videos on our YouTube channel where you can see short videos on how to run through some of the tools. For licensings or evaluations of GDI, please contact sales@bluebackreservoir.com, or you can also go to the Ocean Store for some more information. I'm now just going to jump into the live demo and show you some of these workflows that I mentioned. So inside of Petrel, I'm going to first open up a interpretation window and take a look at my near seismic. And let's choose inline here. And what I'm firstly going to do is make a comparison between the near and the far to see if I have any small AVO effect. So firstly, I'm going to highlight the Blueback Toolbox, and on the right hand side choose the seismic probe. This allows me to draw a little box, and once I've created that, I can choose the settings for the box and I can overlay another seismic. So firstly I'm going to overlay my far, and you can see that I have a definite brightening of amplitudes between the near and the far, especially in this lower part of the section here. It's less so up here. So I think I have a definite AVO effect that warrants some investigation. In this probe I can also overlay my attributes, one of which is a AVO classification volume, and you can see it's dividing up data into different classes. It can look a little bit messy, but as we move down here I see that I have a really nice consistent class 2 and 3 AVO response. So your first question at this stage might be, how have I created this AVO classification volume? So I'm firstly going to show you that. That's part of the Blueback Toolbox and the Reservoir Characterization. So inside this Reservoir Characterization Toolbox, I can firstly create an intercept and gradient by inputting my angle stacks, near, mid, and far, choosing a midpoint of the angles, and when I press apply I get a intercept and gradient created. I can then use a simple AVO classification tool to produce this cube that has colored the seismic by these different classes. So again, here I've input this time my intercept and gradient. If I click refresh here, I get a plot of my data in this classification, and we can start to see data straying away from the background trend. I can also mute certain classes in this plot by applying a trend, and I can also color the classes as I wish, and also produce some strength cubes which tell you how far from the background trend certain points are straying. So let's take a look at what that produces. So here I can see my AVO cube like so, and here I can have a consistent response across the bottom of the seismic, which becomes much more apparent if I show something in the time slice like so, and here I can see a nice consistent response across the bottom of the reservoir. Back in the reservoir characterization box, I can also show, I can create extended elastic impedance cube, which can be used to help to show fluids. So again, I just refresh this plot, and like my AVO classification, I can create a plot here. In addition, in this cube, I can also use a filter, so I can take my far and I can filter the intercept gradient based on the peaks and troughs from my far, and I get a slightly better plot here. So the theory of this algorithm is that approximate best fit to this data will highlight fluids, and I can show that in my 3D window here. As you can see, a nice consistent response across this reservoir zone and a slight dimming of the other amplitudes. So I've created everything I need to then go into some cross-plotting and analysis phase. So I'm going to do that by choosing Insert, New Blueback GDI Investigation. And this pops up my GDI investigation. So this is a central folder for controlling the data, the scales, and the colors that are in your analysis. So I'm going to add some seismic. Firstly, I choose a sort of placeholder, and then I add my near, my mid, and my far. I have some obvious constraints I can use here, like top and base surface or horizon, but in my case I'm just going to use a fixed depth and change the decimation parameters slightly. In the second tab here I can also manage the dimensions and colors of the seismic, and you can see it's quick to override any of the color scales that you have. So finally, let's just give this a convenient name and press OK. And then I can open up a number of different windows that come along with the GDI. So I have a histogram, scatter plot, cross plot, and in this case I'm going to show the matrix window, and then just toggle on my investigation. So here what we can see is that I have my near versus far, near versus mid, mid versus far, etc. across the different seismic. And what we can see is that on the near versus far, we start to get some larger separations from this background trend. I can also color by, for example, my far, and see where that's happening in relation to the different amplitudes. So by looking at this plot, I can see how the background trend of the data is changing across the different stacks, and see that I have a definite separation from the background trend as I progress to my near versus far. So the next step is to integrate the results I produced earlier. So again, I'm going to create a new GDI investigation, again with seismic, and this time I'm going to choose my intercept and gradient, and I'm going to add in my AVO classification and my extended elastic impedance. Again, set up a constraint on time, like so. This time I'm going to choose a scatter plot and toggle on the investigation again. And here we can see my intercept and gradient plot like so, with some data starting to separate out from the background trend. But without matching this to any other type of data, I'm not really sure why that could be. So at this stage it's really useful to bring in, for example, my AVO class volume. And if I color by my AVO class, I then get a nice identification of the AVO class to which these anomalous points belong. So I can see that I have a nice class 2 and 3 area here as the points start to stray from the background trend. So I can add in here, for example, a rectangular filter just to highlight some points, and at any stage I can create a point set inside of Petrel that lets me work in the 3D window. Before I do so, I can see that I have my nice class 2 and class 3 in this area. So what I'm going to do now is use my extended elastic impedance and see where that correlates. So I can see that in the same area of my class 2 and 3 AVO response, I have a consistent bright blue amplitude here from my impedance cube, which may highlight fluids. So in this case, it might make more sense to use a freehand filter and choose these points based on a more precise selection of data. And again, I can also take this and save it to a point set back inside of Petrel. So let's take a look at how those results match up with the seismic. In the first case, I can produce my point set selection based on the AVO class, like so, and then compare that with my angle stacks, for example. So I can see it's made a nice job of selecting this consistent anomaly in the bottom of the seismic. Just turn those off and on to make sure you can see that. And in addition, I can also take my point set from my extended elastic impedance and show how those points correspond with an amplitude from a different piece of seismic. So that was a quick overview to show you how you can integrate the results from different processes back into the crossplot space and then go back into the seismic interpretation space by producing a point set. The final workflow I want to show is also geophysics, but more focused on well data. So here I am going to choose a well, and I'm going to choose VP, VS, density, and V shale, like so, and then press OK. And as I showed before, I can also choose a window. So I'm going to again choose a matrix window and toggle on my data. And here what you can see a bit better is the different dimensions plotted against each other. So here we have VP versus V shale, VS versus V shale, VP versus density, and VS versus density. I can color this by, for example, V shale, and you can start to see a separation of data out into different classes. So here I have almost two very consistent separation of high versus low V shale. In this window, I can add a little selection on these points, and I can see where that data resides in the other dimensions. So I can see how a specific selection of data may have different trends as I move across the different dimensions. We're going to take a look at this data in a little bit more detail in the scatter plot window, like so. And again, we can color by our V shale. And here I see a nice, again, separation of the data. In this space, I can create mathematical equations, but also rock physics equations. So here I have a friable sand model, which matches up quite well with my data points here. I can also change the dimension of this plot from, say, S velocity to density. And in this axis, I can also use my empirical rock physics equations, so I can see my Gardner shale and my Gardner sandstone, which matches really well with this set of points down here. So it's really important in this rock physics domain to make sure that your models match your data, and I can then use them further in other workflows. So I could, for example, use them in a lithology substitution, like so. And in here I can take my rock physics model, input my elastic properties, VP, VS, rho, and also porosity. And in here what I can see is I can change the water saturation, porosity, or pressure and see the response that has on my data in this plot here. So I can substitute the properties of this well. So we have only half an hour for this demo, so I've planned to do a short recap on everything I've shown and then open up for some questions. So I've shown that it's easy to create and manage an investigation of data. You can choose lots of seismic together in one space and constrain it by the same time or depth or top and base surface. Using a single investigation, it's possible to visualize in multiple windows without going back and selecting data. And within the GDI, we have some unique ways of visualizing data like the matrix plot or the parallel coordinates window. We can cross-plot our angle stacks to do a quick AVO reconnaissance to see if I have a response as I move from the near to the far. So this is a fairly good screening technique. I can then go a little bit further and produce a AVO classification cube and bring that into the investigation space as well. So here I have a plot of intercept versus gradient colored by my AVO class. I can do the same with some inversion results. So in this case I've used extended elastic impedance, which can help highlight fluids. And I see a nice consistent correlation between my class 2 and 3 AVO and these bright blue response, or high amplitudes from my extended elastic impedance. Of course, I can integrate back into the 3D space by selecting data on the crossplot and producing a point set, like so. In the rock physics domain, I can crossplot my elastic properties like VP, VS, and rho, and I can overlay some rock physics models, which gives me some high confidence about using the rock physics models in other processes. To save some time, I didn't show this, but it's of course possible to interpret the data on the crossplot and do some geophysical interpretation of logs, like so. Again, for licensing questions and evaluations, please contact sales@bluebackreservoir.com. And for more information, you can also consult the Ocean Store. So I'm now going to open up for the questions that have come in during the demo. Let's take a look at these. So there was a couple of people with technical difficulties. I apologize for that, but we'll put the video online within the afternoon. Is it possible to create point sets and then capture geobodies? We can create the point sets, and then I believe we can use the point sets as a way to constrain the geobody extraction. We can take a couple minutes now to submit any more questions if you have them. Do you have the rock physics template here? I can show that. Inside of our toolbox, we have a rock physics toolbox which you can use to create your rock physics models. So all the standard ones are there, including a user-defined. And once we create a model, we can also parameterize that model based on the settings. Is it possible to cross-plot wells together with seismic data? Yes, that's possible. Inside of the GDI, we can add, say for example, well with VP and then seismic if we have it with the same property. So in order to do plotting of seismic and wells together, you need to have data of the same dimension inside of Petrel. And that's fairly easy to do with your seismic. You need to simply just assign the correct Petrel template here. In addition, the GDI also has some conditioning tools to help with common scaling issues between wells and seismic data. So we're kind of make improvements in there as time goes by. Do we have the AVO classification inside of the GDI? No, we don't. We try to keep the GDI as generic as possible and leave the classification into the toolbox, for example. But it's possible, of course, in GDI to make selections and annotations and split the data into different sectors if you wish. Can you also create user-defined formula? Yes, that's possible. Inside of the create equations, you can add a user-defined equation, which includes some basic mathematical definitions as well as the ability to define using a Python script. Which model did I do the classification in? This is in the Seismic Reservoir Characterization tool, which is a set of tools for doing basic AVO analysis and classification. So it's some simple things like creating an intercept and gradient and doing the AVO classification, but it also has a color inversion and the extended elastic impedance. So with that, I'll just say thanks to everyone for joining. If there's any more questions, please contact us on sales@bluebackreservoir.com. Thanks to everyone who's participated throughout this webinar series, and thanks to everyone in Blueback who helped organize them. Thanks again, and goodbye.